Hello and welcome back to the lab. Today on the bench, let's talk engineering designs, poor design, and why I'm changing some things. First to start, if you saw the previous video about the airline, both of them, and the nitrogen soldering system that we have in the lab, which is some of the whys that I need this much filtration on the compressed airline, I am extremely happy with all the filters, everything. There's no problems. All the problems that we're working on correcting and fixing today are design issues for this airline, which even killed some air tools. So we will get into it and make some changes. But even as I'm looking at this sheet of paper, this picture from the high pressure side, I need more parts. What I was going to do, I can't do, so I need to run over to the supply store and the home goods store and pick up some more fittings. I'm going to need one more T because what I thought I was going to do, I'm not going to be able to do. So this is the high pressure side, unfiltered of the air setup. We have this line right here coming in from the tank, which is over here. This is the just small compressor that I have for right now. It's very noisy and is slowly coming up on the short list of stuff to upgrade. But we've converted it to a permanent install, so we have everything on the system is 3/8. And I thought what I was going to do is have a high pressure side for the garage for dirty air and air tools and things like that. Then I should have a cleaner side that goes through the 3-stage filter, the desiccant dryer, and then a pressure regulator cleaner side out for like paint sprayers and things like that in the garage that need clean air. One of these lines actually comes down into the lab, and then it runs through yet more air filtration. 2 more of these, plus a charcoal filter, where I was very brand picky. The stuff in the garage I wasn't brand picky about. The one downstairs, or the one down here was. I ended up with some Ingersoll Rand air filters, and then that runs through a charcoal canister and things like that. All of that was done to protect the nitrogen generator for the N2 soldering station. Those are very fragile, especially with solvents, so fuel vapor, things like that. With the compressor being in the garage, I did not want to take any chances with it ingesting some solvent and then shooting it out into the airline and eating the N2 filter, the N2 generator. But what ended up happening is I never touched this regulator, and I've never touched this regulator. So I have these set at full pressure all the time. Everything's good. That was working for a while. Yes, I knew I was running the air tools a little hotter than I should, but I was pretty much only filling tires, things like that. No big deal. I wasn't doing any serious air tool work. So none of the important air tools got damaged. However, that does lead me to what did die, which is my tire inflator. I had a spring-loaded tire inflator, and it's now reading about 10 psi off for what the gauge says versus what the trucks are telling me. Doesn't seem like a lot, but 5 to 10 psi can take on a interstate trip. It can take fuel mileage from 19 to 20 miles a gallon down to 16 to 17. So I definitely watch the tire pressure because, for those that don't know, I'm a professional technician and cruise the road a lot. So fuel economy is actually more important than it should be to me. Any fuel I'm wasting, I'm just wasting money. So we killed an air tool. We're going to get this all set up. So what I'm planning on doing is, for the dirty unfiltered air coming from the tank, I want to put a regulator in so I can regulate the unfiltered air pressure at the tank now, or coming out of the tank for the air tools in the garage, i.e. tire inflators, things like that. It's just blow guns, just some generic air tools that I use when I'm working on stuff upstairs. This is what's going to go in. We have a pneumatic plus. Already has some mounting hardware on it for putting it to the board, but we also have a little bit of filtration for the air tools up in the up in the shop. These two filter stages are to protect the regulator. Tank air out of an air compressor is actually pretty disgusting. There is a lot of crap in it, and especially if you're these regulators have some very small orifices in them and things like that, so if they get clogged, they don't work as well or at all. So we have just two stages of filtration. We have a dust particulate filter down to 5 micron, and then a collating filter to get the moisture out. And then we have our regulator. So what we're going to do is on the input side of here, we're going to put a valve that I can turn this off, and then I'm going to get regulated pressure out this side over here. And I got all the fittings and valves and everything to do that right here, so we'll get that all assembled. Where I ran into the engineering challenge right before I hit the record button is, where am I going to put this? So I have high pressure air coming in here, but this is just a manifold, so it's got two connectors, and then it comes up to this regulator. So if I put the regulator here, I'll be regulating the entire system, which I don't want to do. I want 200 psi air here. If I put the regulator here on this side, I can't use this manifold. So what I need to do is I need to tee off the airline coming in, and then put high pressure air, put 200 psi high pressure air into the front side of this and into the front side of this. So I got to put a T in about right here. That is what I did not think of this morning, and that is what I need to go buy. So what I'm going to do is I'm going to run over to the store. I'll pick up that T. It's going to be some 3/8 inch MPT or MIPS for the airline. The other thing that I'm going to do when I built this is, if you can see, I'll zoom in here real quick. I don't know if the camera's going to pick it up well, but on these hose clamps, there's a tail that's right here that's a little long. These were sold as several diameter hose clamps. I think it was, and 3/8 was covered in it, so I'm not using clamps that are too big. I think it was 3/8 to 3/4 or something like that. These are terrible. They create a pinch point on the hose, leak point, things like that. You can tell right here, this is a different size hose clamp, a little bit smaller. These are specifically for 3/8 and 3/8 only. So while I'm in there doing all this stuff, I'm going to change all of these hose clamps because they were just leak points over the year and I was just losing air. So we're going to get into this, get some stuff done, and then I will be back when we start assembling some air toys. Okay. So for those that haven't done a lot of plumbing before and might not know, there is a right way and a wrong way to put on Teflon tape on a fitting, water or air or any fluid. As you turn the fitting in, you want the Teflon tape to be wrapped in the direction of rotation as you're turning the fitting in, because what happens is, as the thread bites, it'll tighten the Teflon tape on the threads, versus if it was wrapped the incorrect way, it will try to back the Teflon tape off and jam up the threads and everything like that. The easiest way I have figured out to remember this, because I always get it wrong the first time because I don't do plumbing that often, is if you're holding this is true for right hand thread. If you're holding the fitting in your right hand, Teflon tape goes over top this way. Now the camera's not going to pick this up at all, I'm sure, but the Teflon tape, as it's threaded, it will... Nope, I did that backwards. Shit. Okay, I got it backwards because I turned the wrong one. It's over the top, like so, and then turn the fitting, not the tape. Now we're tightening. And if it's done correctly, you can see the tail as I turn the tail will just lay flat. But then I turn this the same way. Now it's tightening the Teflon tape on as I'm putting it in the fixture. Have to get some tools out and really crank this down because I do not want any air leaks, and this has to hold 200 psi, which is a lot more than water pressure, at least what water pressure should be. If you have 200 psi at water pressure, there might be problems. As I'm taping these up off camera, in fluid systems, the pressure is actually the resistance to flow, which is one of the reasons why I chose 3/8 airline for all of this, is because some of my air tools need high flow, and I wanted to have the least pressure drop over the tubing or over the lines as I can, especially coming down into the lab from the dirty side of the building. It is it's a decently long run of airlines, so to keep the flow up, I used a larger diameter airline. Some future planning, I do want to upgrade the compressor, definitely to something quieter, and definitely to something more sustained cubic feet a minute, because I do want to get a sandblasting box for the lab so I can start stripping paint off some cases and repaint some stuff and really clean some of this equipment up, get it looking good. But my current compressor is most definitely way too anemic to drive a media blasting cabinet. But if these are things everyone's interested in, let me know in the comments below, and we'll see what we can make happen. Comments can often drive videos. Okay, after all of that, we have a ball valve to isolate this side of the airline. We have a T-joint with the correct barbs, and we're going to get all this stuff wired up to the board. So I will do that, and then I will shoot another picture and then be back. All right, after a bit of work, here's the before and the after. So what have we done? Well, our feed line comes in from the compressor down here up to this T, which then feeds this filter and regulator network, which then comes down to these 3 lines for dirty shop air. And then we have this other feed line that comes up into this regulator system, which does a much better job of filtering and regulating for clean shop air. These two tails are up in the shop upstairs if I ever want to run a paint gun. So all of this stuff is I wouldn't run a spray gun with this air because it needs to be dehydrated and filtered. This line's the one that runs down to the clean lab to feed the nitrogen system, as well as the bench air for the shop. One interesting thing to note is way down here, there is a black connector. These are high flow connectors, and I put one on the new tire inflator that I got, which I'll show here in a second. The orifice is a lot bigger, so that hole is pretty chunky for a 1/4 inch quick connect. So you get a lot more air through the couplers and the quick disconnects. Yeah, I do have one down here, especially for blowguns, which I need to actually change this out now that I look at it. This is a low flow coupler. This is a high flow coupler, so you can see the difference in orifice size between the two. This is the high flow female side. So let me get this swapped out real quick, since I have the wrenches down here in the lab, and we'll get this put on the blowgun. In addition to putting the high flow coupler on the glue gun. I also put some Teflon tape on there because this thing keeps wanting to come loose. And just because we trimmed it down to the correct length so it looks good. There we go. And here is all the parts of shame. So these are the crappy 2 large hose clamps, and this geometry right here is what caused me no end of grief. I don't know how well the camera's going to pick it up, but it left a pinch point in the hose, which pulled the hose out this way, and I got a leak path at the airline. So all of these are gone. They are now the appropriate size clamps, and all of this hose got trimmed off, not to be reused because it was leaking air. Parts of shame. Okay, so what caused all of this? Well, here's what I damaged. This is the tire filler that we had for a while. Actually, I am going to salvage this before I toss this. What would happen is the gauge would pop out of here at the tire pressure, but when you squeeze the valve, it would put 200 psi here, and it would just peg this gauge, just and done. I got away with it for a little while, but over time it beat up the spring in here too much, decalibrated the unit, so it was reading about 10 pounds off. Not great for filling tires, because it was actually reading, the spring weakened, so it would come out too far, so it was actually reading 10 pounds high, which caused your tires to be 10 pounds low. So this is what broke and what caused me to do all of this today. Here is the new one. Not sponsored or anything. This is just the one I picked out. This one's got a digital readout on it. So it'll be easier for some of the other people that need to use it to use. And I did put a high flow coupler on it. Actually, that's a pretty good example there too. The difference, just the difference in orifice size between the high flow and the standard. So that should end up equating to quicker filling of tires, especially since some of my tires are now pretty big and need quite a bit of air. One other thing to note is I had to switch back the coupler on the end of the tire inflator. These high flow couplers would not connect with a low flow male end, so it'll only connect with the high flow male ends. So I have to get some airline that I can use high flow couplers and high flow couplers with. But that'll be for another project. Today I've just switched this back so I can get some air in some tires. Thanks for stopping by the lab and taking a look at this video. If you have any questions, comments, or suggestions, leave them in the comments below. I do read all the comments. This was work that I've been needing to do to get the nitrogen system back up and working. So now that that's done, we can get on with some more restorations here in the lab. As always, I will see everybody in the next video. More is always on the way.